my fellow deep sea dwellers. I am Sonari, and I will now be reading the Wikipedia page for Deep Sea Creature. The term deep sea creature refers to animals that live below the photic zone of the ocean. These creatures must survive in extremely harsh conditions, such as hundreds of bars of pressure, small amounts of oxygen, very little food, no sunlight, and constant extreme cold. Most creatures have to depend on food floating down from above. These creatures live in very demanding environments, such as the abyssal or hadal zones, which being thousands of meters below the surface are almost completely devoid of light. The water is between 3 and 10 degrees Celsius and has low oxygen levels. Due to the depth, the pressure is between 20 and 1,000 bar. Creatures that live hundreds or even thousands of meters deep in the ocean have adapted to the high pressure, lack of light, and other factors. And now we can look at evolutionary adaptations of deep-sea creatures. Lack of light. The lack of light requires creatures to have special adaptations to find food, avoid predators, and find mates by creating their own light or having an ability to see in the dark. Oh, I love the dark. Lack of resources. At this depth, there is not enough light for photosynthesis to occur, and not enough oxygen to support animals with a high metabolism. To survive, creatures have slower metabolisms which require less oxygen. They can live for long periods without food. Most food either comes from organic materials that falls from above, or from eating other creatures that have derived their food through the process of chemosynthesis, the process of changing chemical energy into food energy. Because of the sparse distributions of creatures, there is always at least some oxygen in food. Also, instead of using energy to search for food, these creatures use particular adaptations to ambush their prey. In turn, these creatures rely on large food particles, such as fragments of dead fish or other marine mammals, to fall from the surface. Although the falling food can support the population of the deep-sea creatures, there can still be a lack of resources due to a middle population of fish consuming the fragments before making it to the bottom. Deep-sea vertebrates also have less muscle and less ossified bone. This lack of ossification was adapted to save energy when food is scarce. Bioluminescence is the ability of an organism to create light through chemical reactions. Creatures use bioluminescence in many ways: to light their way, attract prey, or seduce a mate, or in my case, never seduce anyone. Many underwater animals are bioluminescent, from the viperfish to the very species of flashlight fish, named for their light. Some creatures, such as the anglerfish, have a concentration of photophores in a small limb that protrudes from their bodies, which they use as a lure to catch curious fish. Bioluminescence can also confuse enemies. The chemical process of bioluminescence requires at least 2 chemicals: the light-producing chemical called luciferin, and the reaction-causing chemical called luciferase. The luciferase catalyzes the oxidation of the luciferin, causing light and resulting in an inactive oxaluciferin. Fresh luciferin must be brought in through the diet or through internal synthesis. I'm sure I mispronounced half of those words. Yeah. Chemosynthesis. Since at such deep levels there is little to no sunlight, photosynthesis is not a possible means of energy production, leaving some creatures with the quandary of how to produce food for themselves. For the giant tube worm, this answer comes in the form of bacteria. These bacteria are capable, in general, just capable, I screwed up the words, of chemosynthesis and live inside the giant tube worm, which lives on hydrothermal vents. These vents spew forth very large amounts of chemicals, which these bacteria can transform into energy. These bacteria can also grow free of a host and create mats of bacteria on the sea floor around hydrothermal vents, where they serve as food for other creatures. Bacteria are a key energy source in the food chain. This source of energy creates large populations in areas around hydrothermal vents, which provides scientists with an easy stop for research. Organisms can also use chemosynthesis to attract prey or to attract a mate, which seems to be what most of these things do. Deep sea giantism. It's gigantism, isn't it? Damn it, I screwed it up! Stupid Sonari. The term deep sea gigantism describes an effect that living at such depths has on some creatures' sizes. Compared to the size of relatives that live in different environments, these creatures are generally many times bigger than their counterparts. The giant isopod related to the common pillbug exemplifies this. To date, scientists have only been able to explain deep-sea gigantism in the case of the giant tube worm. Scientists believe creatures are much larger than shallow water tube worms because they live on hydrothermal vents that expel huge amounts of resources. They believe that since the creatures don't have to expend energy regulating body temperature and have a smaller need for activity, they can allocate more resources to bodily processes. There are also cases of deep-sea creatures being abnormally small, like me, such as the lantern shark, which fits in an adult human's mouth, which I don't want you to do to me. No, don't even think about it. Deep-sea research. Humans have explored less than 4% of the ocean floor. And the game reset me. Oops. Yeah, that would happen if I stand around for too long. And dozens of new species of deep-sea creatures are discovered with every dive. The submarine DSV Alvin, owned by the U.S. Navy and operated by the Woods Hole Oceanographic Institution, Hui, in Woods Hole, Massachusetts, exemplifies the type of craft used to explore deep water. This 16-ton submarine can withstand extreme pressure and is easily maneuverable despite its weight and size. The extreme difference in pressure between the sea floor and the surface makes the creature's survival on the surface near impossible, unless you're me. This makes in-depth research difficult because most useful information can only be found while the creatures are alive. Recent developments have allowed scientists to look at these creatures more closely, and for a longer time. Marine biologist Jeffrey Drazen has explored a solution, a pressurized fish trap. This captures a deep water creature and adjusts its internal pressure slowly to surface level as the creature is brought to the surface, in the hope that the creature can adjust. Another scientific team from the Université Pierre et Marie Curie has developed a capture device known as the periscope, which maintains water pressure as it surfaces, thus keeping the samples in a pressurized environment during the ascent. This permits close study on the surface without any pressure disturbances affecting the sample. See also abyss box and deep sea fish. And I hope you've enjoyed Sonari reading out the Wikipedia page for deep sea creatures. Maybe next time we can look at deep sea fish in particular. That could be interesting. I love my ocean brethren. Ha ha ha. I I hope you enjoyed me reading through the amazing Wikipedia article. I appear to be drowning. Well, the human is drowning. I'm fine. Anyway, if you liked the video, be sure to leave a like, and why not subscribe to the channel for more content like this, and ring that notification bell. It does something, and I still don't know what. And follow me on Twitter for updates, and to see the thumbnails in a larger size, as well as announcements of streams. And they drowned. Goodbye, everybody, and roll the outro! Bar, grr, gar, rar, grr, nyar, grr, nyar, bar, grr, nyar, brr, nyar. I'm not scary.
I gave that bastard what he deserved. A funeral. Fit for a king.